My name is Sean Mackey. I'm the division chief for pain medicine at Stanford, so I work up the road where I oversee the clinical educational and research missions. I take care of patients about 1 day a week, and the other 6 are typically in the lab doing pain research. I focus a lot on cognitive neurosciences, but I'm not going to show a single brain picture today. I did get this warm and fuzzy feeling when you were talking about machine learning, because I'll have a session on that on Thursday about brain predictors to use machine learning techniques. I'm excited to be here. Appreciate Dan inviting me for this. I'll share with you I've learned a lot. One of the most important things I learned from the introduction is I actually have a Wikipedia page. Until about 30 minutes ago, I had no idea. So I went online to check, and sure enough, my 17-year-old son has done a Wikipedia page on me, so thank you. Unfortunately, there's nothing embarrassing there to the best of my knowledge. I'm also the president of the American Academy of Pain Medicine. I follow esteemed colleagues like Matt Gallagher and Dan Carr, who most likely will be taking over in 2 years. I mention this insofar as the Academy is putting in a big effort on acute pain. We have developed this year an acute pain shared interest groups that's led by Trick Buckmeyer, that Dan has been overseeing as the Vice President for Scientific Affairs. We'd like to see an opportunity for us to work together with this special interest group to help further promote acute pain, its care, prevention, and research in the United States. And I know Matt is very interested in advancing this within the journal that he's the editor-in-chief of, Pain Medicine. I'm here to talk with you about CHIOR. And this is the acronym for a Collaborative Health Outcomes Information Registry. This is a platform that we developed as a health outcomes platform that's now morphed into something much more than what was originally intended. Its motivation was based on about 15 years of my collecting outcomes data in our clinic, but then from a more contemporary standpoint, was nicely stated, illustrated by these 2 Institute of Medicine reports that came out. The first one was an Institute of Medicine report on pain that I was honored to serve on and helped co-author, where we wrote there is a need for greater development and use of patient outcome registries that can support point-of-care treatment decision-making, as well as for aggregation of large numbers of patients to enable assessment of the safety and effectiveness of therapies. And this was the original motivation, was to develop a health outcomes registry that would initially focus on pain but grow much greater than that in specialties. What it's turned into, however, is what's illustrated by the second quote by the other Institute of Medicine report on learning health systems. That is, we seek the development of a learning health system in which science, informatics, incentives, and culture are aligned for continuous improvements and innovation, with best practices seamlessly embedded in the delivery process and new knowledge captured as an integral byproduct of delivery experience. It's taking a simple registry, if you will, and it's turning into something using advanced analytics to actually improve patient care, quality improvement, process improvement. I'm going to show you about some of that. I threw these slides in. This is a talk that's usually an hour. I cut it down to about 20 minutes or so. I left these slides in. This is Sandra Hyde, if you see her picture come up. She's a patient of mine who flies in from Walt Disney World for me to treat her CRPS. And she illustrates the common problem with randomized controlled trials that I think was beautifully illustrated in the morning's topic, and that is about 90% of people don't qualify for a simple randomized controlled trial. The problem being that those 10% who get in don't look anything like the patients we see in our clinic. I'm going to show some data from our brain imaging work on Thursday where I screen about 10 people for every one that I bring in to a trial. And the problem is when you go through the multiple phases, this is the FDA phases of treatment authorization in the US, that when you get the treatment authorization and you get approval for the drug, the problem is, again, this was based upon patients who don't look anything like Sandra, and so oftentimes that drug doesn't work for her. We have no way of knowing whether it's going to be effective or not. And so that, again, was part of the motivation for this. The motivation to develop CHIOR, which was to develop, implement, and expand an open source, open standard, highly flexible, and free health and treatment registry, and ultimately extend that into a learning health systems. It's used to collect outcomes data on large numbers of patients from chronic pain and other health conditions to be used for point-of-care decision-making, comparative effectiveness research, longitudinal outcomes research, and the new buzzwords these days, it was alluded to earlier, and I'm just going to emphasize, is this concept of large, simple trial designs. It's using your clinic as a laboratory, large numbers of patients that you bring in, and you do practice-based efficacy trials, and then also to integrate the analytics for software-based decision-making into a true learning health systems. This is the platform that we developed several years ago now. I've kept fairly quiet about this as we've just been slowly building the system over the last number of years. because I wanted to make sure that we had something solid before we came out and talked about it. So it's built upon a client-server-based approach. It is, by the way, and let me be very clear, it is an open source, open platform, and free system. Free, my favorite four-letter F word. So it integrates in a variety of users and developers, external registries with the idea of aggregating data. And I'll show you more about that momentarily. At the very beginning, we had to make this very simple to use. When I went and talked with other providers across the country about this, they all said, Mackey, if this takes more than a few minutes for our staff to use, the providers to use, it'll never succeed. It has to be incredibly easy. So we made it incredibly easy. We got the staff, we got providers involved with the development of it. We have data import structure from EMRs to bring in all sorts of demographic and treatment data. And again, we provide point-of-care decision-making for its use. The framework of it is to build initially a base of CHIOR and then add on additional modules. And so we've added on modules that deal with headache, orthopedics, GI. We have this in primary care at the University of Florida, which I'll talk about momentarily. And then we used industry standard tools. So nothing that's esoteric, all easy, off-the-shelf tools. Some of them more expensive, like Oracle backend database, do cost money. We have also ported this over, by the way, to a free database version that's available. And then we leverage the NIH PROMIS system using the computer adaptive testing tools. And I'll talk with you momentarily about PROMIS. One of the things to mention is people sometimes confuse what we're doing and then also with some of what the DoD is doing as saying this is PROMIS, and this is not PROMIS. This is a delivery platform that happens to use some of the PROMIS item banks. And this was funded through a partnership with the NIH Institute directors. About 13 of the Institute directors have provided some money out of their petty cash drawer, and then I've augmented that with a lot of my endowment money. The question I often get asked is in developing this type of a system, whether it be for the outpatient or the inpatient, why don't you just use your EMR? And we use Epic in the US. Epic is the most commonly used one for academic institutions. The short answer is you can't do it. The computational demands of modern PROs, patient-reported outcomes, using computer adaptive testing and IRT, item response theory, far outstrips what you can do with a standard EMR. And the type of analytics that you would do in real time for a learning-based system far outstrip anything that EMRs were ever designed to do. You have to actually run this separately. I use the analogy, it would be like building a word processor but limiting yourself only to a query or font. And so the basis of this is that it runs on all systems. It's agnostic. It will run on your PC or Mac, it will run on your smartphone, it runs on your Android, your iPad, you name it. As it stands right now, about 65% of people in our clinic are completing this at home, about 35% are in the clinic. And then what we're seeing here is while the majority are using PCs, we're getting a larger use of smartphone technologies. These numbers here in the bottom, iPhone, iPad, and Android are continuing to increase with time. I said that we're leveraging the NIH system, the NIH PROMIS system. So let me take a moment to describe that to you. The NIH PROMIS system, if you're interested in doing PROs, patient-reported outcomes, and you don't know about PROMIS, I really encourage you to get onto their website and get educated. This is the future. The NIH has dumped now about $110 million into developing a new series of patient-reported outcomes. What they've done is they take all the standard type of outcomes you've done and medical, psychological, social domains and recast them using item response theory from the psychometrics and fields of education and then applying computer adaptive testing. It is free. So what we do is we download the item bank, we run it all locally, and I'll talk with you about that momentarily. And the purpose, the reason for doing this is to address the limitations that we see in standard PROs. Many of us have all used classical testing instruments to capture domains such as depression, anxiety, physical function, fatigue, pain interference, right? And the problem that you run into with all those instruments are several-fold. One, you run into problems with characterizing the domains at both the floor and the ceiling. I'm going to show you what I mean by that in just a moment. Two, you have issues with precision. Three, you have issues with comparability across patients. Many of them were validated for specific certain populations that don't then allow you to cross over to others. Four, there is problems in that they often cost money. These are often proprietary instruments that you have to pay for. And so the purpose of PROMIS was actually to have a system that was responsive across multiple populations, that was responsive at floor and ceiling, high degrees of precision, and high degrees of efficiency. So let me give you some examples. I think many of us are in the room that are old enough now that if any of you have ever taken any of the standard aptitude or admissions tests. In the United States, we have the GRE, the MCAT, the LSAT, and I'm sure in your countries you all have your various aptitude tests that capture math ability, learning ability, writing and reading ability, and you have your own acronyms for that. And the usual routine is, if you remember back, we all walk in, we sat in that chair with our number 2 pencil, and we stayed all day there to fill out the little bubble sheets. And then what happens is that you get your score that's added up at the end of it. And let's imagine that this is on a math domain. And at the end of it, you get your 73. Well, the way it works with IRT is that every question has a statistical probability distribution to it. And what you do is, let's imagine you're measuring math ability. You start with a question that's in the middle of the domain at 50. And let's say it's an algebra question. If you get that right, it then goes up and asks you a harder question in the area, say calculus. You get that wrong, it moves to an easier question. You get that right. It now very quickly nails you down into where you are in math. In the graduate, I think it's the GRE, when I took it for my PhD entrance, I had to go and spend the whole day. Nowadays, within a few questions, they can figure out what your math ability is and be done with you. Now, the truth is they keep you sitting in that chair all day long because they have to justify the $1,000 they charge you for that exam. But this is all based on the fields of education. It's now being translated over into medicine. At Stanford, both on the inpatient side in acute pain, but also in chronic pain, I take care of patients at the huge end of the range, people who are bedbound, dying with end-of-life cancer or very debilitated, all the way to people who are NCAA athletes and everything in between. The problem with classical tests is they fail you at these extremes. I take care and have taken care of a young woman who's now a professional volleyball player who had some neuropathic pain in her leg. And if she were to fill out Charlie Cleland's brief pain inventory, great instrument for measuring pain interference, she would just laugh at it. She would laugh at it. She was like, this is meaningless to me. This doesn't capture my problem. My problem is that my pain, takes about this much off of my height when I'm trying to spike a volleyball. And I need help with that. So enter promise. Promise allows you to get the wide range and the high degree of precision and allow you to capture it very, very efficiently. And I'll show you how efficiently in just a moment. There's another benefit to promise. The other benefit is it gives you a normative statistic. It gives you everything in terms of a t-stat. And that t-stat has got an average of 50 and a standard deviation of 10. And what that means, and it's normed against the entire US population, that means if you have a 65 on, say, depression, you are 1.5 standard deviations above the US mean. And that means it's comparing you against the 337 million Americans in our country. And by the way, there are now more and more of these normative stats that are being applied to other countries, and it's been translated in a multitude of other languages. So, the current status. We rolled this out in August of 2012. We've now got over 5,000 unique patients, about 12,000 longitudinal data points. It's actually more than this. It's probably between 5,000 and 7,000 and about 14 to 15 longitudinal. We took and implemented our own local computer adaptive testing engine at our site. I can talk more about that in the Q&A. Traditionally, when you use the Promise CAT, you're pinging the Northwestern servers, and what we found is that the latencies were problematic, and it allowed us to optimize by bringing it in-house our own stopping conditions. And more fundamentally, it's changed entirely the culture of how we practice pain at Stanford. We use this information on each and every patient to help inform us about treatment decision-makings. The briefest about our center, we're a major tertiary coordinated referral center. I've got 21 faculty on my staff. They're all pain boarded. They come from all walks of life, from a primary specialty. I think we employ more pain psychologists than any program in the US. And we built an infrastructure that we then build upon that, multiple subspecialty pain programs all working under one roof. And so that's the group, that's the type of patients and the treatment facility that we use. People always ask, yeah, well, how efficient really is it? Well, here's what the numbers really come down to. For an initial assessment, which is a very large demographic assessment, as well as it was 10 of the promise domains: pain intensity, pain behavior, pain interference, fatigue, physical function, depression, anxiety, anchor sleep, pain catastrophizing, which is a traditional measurement, takes about 22 minutes. For the follow-up survey, though, without all those demographics, about 9. about 9 minutes to capture all of that. We've now, by the way, moved into 14 of the promise domains and other classical tests, and it's only taking a little bit more. You get a survey at the point of care for using to track longitudinal assessment of your patient. And just to give you the numbers on really how this type of PRO really helps benefit the patient and reduces patient burden, let me give you an example using 9 of the promise domains. So if you capture these 9 promise domains, and this is using real data from thousands and thousands, tens of thousands of assessments, it takes on average about 4 to 5 questions to get a very, very tight standard error of that domain. And adding it all up, it's about 39 questions. If you pick traditional instruments and you add up the number of questions they would have to answer, it's 132. What that translates to is about a 71% reduction in patient burden. That means you can capture the broad swath of medical, psychological, and social functioning in just a few minutes. And this is, by the way, without optimizing the CAD engine. We've now recently been kind of tweaking the CAD engine to get that efficiency even better. We've been using this system from both a research and a clinical practice. Those items in red are where we have been actively going to generate preliminary data, use dynamic studies of pain, system studies of pain, and then in the clinical practice on the individual patient, and then to track longitudinal aspects. And the whole purpose of this also is to address the needs of what has been put forward from the National Institutes of Health, which is to develop high-throughput technologies to translate scientific discoveries into improved care. And the problem that we've had with this in the past in using standard types of registries has been multifold. We've had issues with the subject burden. These registries typically take too much time for people to fill out. There's been issues with incongruencies between the EMR and the electronic data capture systems, and then the generalizability of the data. And we put forward that we've broken all of those barriers down. This is a conceptual framework. Many of you in the back can't see this, but when you think about the biopsychosocial aspect of pain, these are many of the components that you would see with path analyses associated with it. And we make the fellows all memorize this by the end of the year. And so this is, not really, this is what's going on with our patients. And so we use this data from a systems level standpoint, and this is some of the initial data that we've used from many thousands of patients to develop a path analysis to identify what are the factors that are leading to impaired physical function and pain interference in our patients. And what we're finding here, and this is a paper that's currently under a final review, is that fatigue really is playing a huge role in that path of determining pain interference as well as physical function. Something we probably all intuit, but having this large amount of data really allows us to drill this down to a detailed level. We can also investigate large groups of patients from a longitudinal standpoint. And so what we find, tracking people over time, is that we get 2 clusters of patients. We get responders and non-responders. What you have here, by the way, is pain interference on the y-axis, physical function on the left. And what you want to see are patients over time moving down. You want to see them moving down like these red circles here. And what we see is we have groups of patients that actually do that with interdisciplinary care, and we see others that are stuck. And what we've identified is that there appears to be this energy function, this barrier, that if you can get them over the first hump, what you will find is that they will actually get better and continue to get better. Right now we're analyzing this to determine what are the factors that distinguish this group of people from this group. And then you can also get metrics related to your clinic. And so I mentioned that you get a T-stat with an average of 50 for the US population. These are umpteen number of thousands of patients in our clinic that show the distribution of many of these promise domains at a clinic standpoint. And what you see is the following. The gray is the US population distribution, by the way. And remember, 10 is a standard deviation. What you find is our patients are severely impaired across all domains of medical, psychological, and social functioning. They have tremendous degree of depressive symptoms, fatigue, anxiety, and clearly pain interference. Bringing some closure to this, we talked about it from a systems biology standpoint. If you look back in time, and it's useful to have a historical perspective on things, you find that the original ways of investigating gene expression were through standard Western blots. You do Western blot by Western blot to look at a single gene expression. That field was revolutionized by the gene expression microarray. and then really put to use in this landmark study in 1999 by Landro, who investigated clusters of gene expression to separate out two clusters that define AML and ALL. And more recently has been using this type of clustering approach to actually investigate cellular mechanisms. Now imagine applying that same type of technology to our patients at a broad scale. What you have here across the top there are different PRO-based domains and a hierarchical linear clustering. And what you find is that you get the usual patients here that have high degrees of emotional distress, high degrees of physical impairment. But there are groups of people down here, these are the ones that have the green aspects when these emotional distress areas, who have high degrees of pain, high degrees of physical impairment. But these people are happy, they're not angry, they're not depressed. What makes them different? Do these people have high degrees of resilience? And is there something that we can learn from them to take those characteristics to help them translate it to our other patients? So where are we now and in the future? We're building specific practice modules in both pain psychology and physical therapy, multiple conditions. We've already developed a clinical note generation where it will take the information from the output and it'll write a clinical note for you. I'll get back to that. We've integrated in software-based decision support. We're starting off with opioid risk and recommendations for referrals. We've got integration in with Epic EMR through our collaboration with the University of Florida. And we're also starting to consolidate in with biometric devices. And so many of you may wear the Fitbit or the Basis or the Jawbone. I carry a bunch of them. Most of those companies are in the Silicon Valley Bay Area, and so we have collaborations with them to get objective measures of activity. We're working getting that integrated in, and then also passive metadata off of your cell phone that's highly informative about how you're actually doing. Get to in the Q&A. How does this directly relate to this group's interest in acute pain? I would say dramatically. What we're doing now, in collaboration with the APM and the Acute Pain SIG, is to extend CHIOR into a perioperative realm. We know, and the data is becoming overwhelming now, overwhelmingly clear, that preoperative factors have a huge impact in predicting whether somebody will have persistent pain after surgery and persistent opioid use. I have 2 papers out there right now that characterize some of those factors using survival curve analysis, that we capture people before surgery, we track them every single day until their pain goes away, their opioids go away. And there's more and more papers coming out. And so the information that we get on people before they ever come into the hospital, we find that that information has more predicted value on how they're going to do than the actual surgery itself. And so we're now we're now extending CHIOR into the perioperative realm to capture data before surgery, during surgery, and then after surgery, and then integrate that in with the clinic aspect. Ultimately, we want to take this information to identify mechanisms also that can be used in the basic science realm and targeted. So I liken it to, I call it from bedside to bites to bench and back again, is the tagline on this, to integrate in all sorts of biometric data with CHIOR and then use that to inform our patients. And closing out, we're looking for collaborations here. We put this into pediatric pain clinics. We're working with other academic medical centers. It's free. It's free. I've only got 2 licensing restrictions on it at this point in time. You can't sell it. You can't monetize it, in other words, and you can't just redistribute the code at will. Otherwise, you can do whatever you want. You can call it whatever you want. We are looking for postdocs. I have an NIH T32 training grant. If you're a U.S. citizen, I have free funding for people who want to do research, and my thanks to our collaborators.